Ah, another peaceful day at Hardy's Winery. The sky is blue. The grapes are growing. Nothing to hear but... Wait, what? They're opening a petting zoo? I knew I should have just gone to the spa. Well, we're here now, so might as well get to it. In this sketch, we're going to cover the processes that cause populations to gain genetic variation. Let's start over here at this pool, which represents a gene pool. The gene pool is the collection of all the genes and alleles carried by the members of a population. You can think of it as the total pool of genetic information that's floating around. Genetic variation describes how many different alleles a population's gene pool contains. We've represented variation with this diverse assortment of allele flowers floating in the gene pool. Diversity is crucial to maintaining the health of a population. Without variation, a population cannot evolve to be better adapted to its current environment, because variation is an absolute requirement for evolution to occur. Variation also ensures there is enough phenotypic variation that at least some individuals can survive environmental changes. Plus, variation helps prevent harmful alleles from becoming too common. Now, let's take a look at how genetic variation can increase in a population. Brand new alleles are created by genetic mutations. You can see there are some mutant allele flowers entering this pool by the barrel of radioactive goo. These flowers represent new alleles created by mutation. Now, most mutations will not lead to the formation of new alleles because most mutations don't impact the structure of the gene product at all. However, in rare cases, mutations can change the protein product expressed by a gene and cause a new phenotype to emerge. In these cases, mutations can be an important source of genetic diversity. Now, take a look at this barrel of wine flowing into the gene pool. It represents gene flow. Gene flow is the transfer of genetic information from one population to another. When new alleles enter a population that weren't created by a mutation, it is due to gene flow. Gene flow occurs when individuals move between populations and reproduce. If an allele or gene is present in one population and not the other, gene flow can introduce this new information to a population. Someone's going to be upset about all that wasted wine. Oh, looks like someone else is swooping in to get some wine. To represent immigration, she's moving from the population of birds in the sky to this population of swans in the gene pool. But we won't tell them that she's only here for the free booze. As you might already know, immigration is the movement of individuals from one population to another. Immigration is one of the more common causes of gene flow. Yikes, these two swans need us to keep out so that they can outbreed. Outbreeding is when distantly related individuals mate. If the two individuals are from different populations, outbreeding can introduce new genetic information to a population. Even if they are from the same population, their offspring could carry a unique combination of alleles. Alright, let's give these lovebirds some privacy. Take a look at this leaky trough. It represents genetic leakage, which is another process that can increase genetic diversity. Leakage occurs when genetic material transfers between closely related species. Hybrids, the offspring of two different species, are infertile when they try to reproduce with other hybrids. But some hybrids can reproduce with one of their parent species. When this happens, DNA from the second parent species ends up in their offspring and thus introduces new genes or alleles to their population. This idea is a little bit complicated, so let's take a look at this interspecies buffalo cattle family for context. In the first generation, a cow and a buffalo mate and create a hybrid beefalo. Two beefalo couldn't reproduce, but this beefalo can reproduce with a cow. Now, the offspring of the beefalo and the cow has about 3/4 cattle DNA. So they'll be classified as cattle and more or less look like cattle. Nonetheless, these offspring are carrying some buffalo DNA that they will spread through the cattle population when they reproduce. And bada bing, new genetic material for the cows. Alright, I'll give it to them. This wasn't the peaceful frolic in the countryside I had in mind, but those beefalo are actually pretty cool. We better get a move on though. Let's take a look back at what we saw at this winery menagerie. Genetic variation describes how much different genetic information there is in a population. Populations with more genetic variation tend to be healthier. Mutations can increase genetic variation by creating brand new alleles. Gene flow can also introduce new alleles to a population, but it occurs through the transfer of genetic material between populations. Immigration is the form of gene flow that occurs when individuals relocate from one population to a different population. Outbreeding is another type of gene flow that occurs when distantly related individuals of the same species reproduce. Outbreeding can introduce new genetic material to a population or create offspring with unique mixes of alleles. Finally, genetic leakage occurs when DNA is transferred between different species that are closely related. This allows new genetic information to enter a species' gene pool. Well, I could chill with these beefaloes until the cows come home. Oh, yeah, they are home. Guess I better get out of here.